delta dash, that would be the transition function for your DFA, right? The one we're trying to find. This delta here, that's the transition function for the NFA. Okay? And so what's going on here? Well, have a like this. These are the machines in the current state of R, big R. And what's big R? It's the state of your DFA. Remember? And a state of your DFA is a subset of Q, subset of the states of Q. And what's Q? Q is the set of states of your NFA, right? Okay, now assume each of these states is different. Okay, because if some of them are the same, by union, like what we're going to, this union trick that we're going to do here, we assume got done before. So let's assume that the states here in these machines are all different. Okay, so we don't have any redundancy. All right. So what are we doing here? Now this is the delta for your NFA, right? It's delta. It's not delta dash, and this current state Ri is one of these. Okay, so you see Ri belongs to R, and R is your current state of your DFA. Okay, and let's say we've got 4 of them. Okay, so we're going to union the next state that comes from this one, this one, this one, and this one. Okay, so we will be unioning 4 subsets. Now, one of them, in fact, is the null set, right? Because that had no next state. That one died. Okay. So we will union this set here with 3 states, and this one with 2 states, and that one with 3 states. Okay, so this union will be over 4 sets, well, subsets. Okay, and this Ri here, little Ri, refers to, that would be like R1, R2, R3, R4. So the Ris, these little Ris, they are members of this. In other words, these 4. Okay. And what is this? Well, that's the state, that's the transition function for your NFA, and that is the state, like this one's state, like there'll be little r1, little r2, little r3, little r4, let's say. And what's this doing? Well, it's telling you what the next set of states will be for the NFA, right? So say that's R1, well then this delta will give you these 3, okay? And if it's R2, this delta will, well, nothing. And if it's R3, it'll give you these 2, okay? And if it's R4, it'll give you these 3, right? And then to get rid of the repeats, the redundant machines, with the same state, you do the union. This union trick is to get rid of repeats. Okay, so in other words, so your set of states here now, once you union them, so after you union these, well, 4 but 3 in practice, 3 subsets, you'll thrown out the repeats, and that will become your R next, and then you can proceed on. Okay, so I hope that's clearer, and now you understand where this comes from. Once you've got a fairly clear visual picture of what's going on, then the math takes on more meaning. So a valuable lesson here. When you look at the math and you sort of shake your head, what the Go back to what the math is representing and make sure you understand the model, the visual, inverted commas, some picture or image or something. Understand what's going on, and then translate what's going on in terms of the math. Okay, so start with a picture and then go to the math. I guess that's the take-home message. All right. Okay, so hopefully that clarified. Now we're in the middle of listing the formal properties of the DFA, the equivalent DFA. So we're up to 3. Now remember the equivalent DFA. What are we saying here? Yeah. So we're now finding the formal description of this equivalent DFA, right? And we've done 1 and 2. The alphabets, I think, were the same. I think we assumed that. So capital sigma is the same. We talked about in the previous session and now visually we talked about the transition function delta dashed. So that just leaves what the starting state is and what the final set of final accept states are for this equivalent DFA, right? This DFA that's equivalent to a given NFA. Right. So what's the start state for the DFA and what's F for the DFA? And dashed each time, because the dashed means we're talking about the equivalent DFA, right? If it's not dashed, they are the properties of the NFA that we start with. Okay, clear on that? All right. Now remember the properties of your DFA. The states of your DFA. They're subsets. Right? They're a set. Each state of the DFA is some set. Okay? So the starting state Q0 in your NFA becomes now a set. There's just one starting state. So the Q0 dashed, that's the starting state of your DFA, will be a set of the starting state of your NFA. That's the starting state of your NFA. Okay? And by making it an element in a set, that can become the starting state of your DFA, right? Dashed, Q0 dashed. Okay, so just do that, and that that's what I've just said is here. All right, so that's the starting state. Now, what about your F? Well, actually F dashed. How do you decide whether your DFA accepts or not? Right? Well, again, let's go here. Now let's say the symbol here is the final input symbol. It's the last symbol in your input string. Let's say it's the final one. Well, then you go looking at each. Well, we may as well union again. Okay, so imagine we've unioned these, so we don't have to check any multiples. There are no copies. There are no machine copies. They've all been thrown out because of the union. Okay, so we then look at the result of the union, and we look at each of these final states and check whether any of them. We only need one. So we go checking to see if there's at least one. In fact, once we got one, we don't bother checking the others because we've got success. Our DFA will give the result accept, because right? We only need one of these branches to accept, and then the whole NFA accepts. It's the definition of accept when you're talking about NFAs. Okay. So we union it. We union this. Let's say this is the final level, the lowest level. Okay. This input symbol here is the last one of the string to go in. Let's say we union this, and then we look at each one to see if that state. Now it'll be a state of your Q, right? Big Q. In other words, a state of your NFA, right? And we check to see if that, for each one, for each state, if it belongs to F. F, right? Now what's F? That's the set of accept states of your NFA, right? Because these states here, they're all states from Q, right? From your NFA, right? So if just one of them, one of those states here, belongs to F, belongs to, is one of the accept states of F, big F, then this whole machine accepts, right? So that's all it's saying here. So R, R is this unionized. So the redundant ones are thrown out. So if this R here contains a member that belongs to F, then so if your R, big R, remember that's the state of your DFA. So it's a subset of your Q dashed, of course, is the superset. Remember. So for any possible R, if a member of that subset belongs to F, then accept. Your DFA should accept, right? And that's what it's saying here. So the DFA, your machine M, so it accepts. Well, it's sort of harder. So if any one of the, after you've unionized, if any one of these is an accept state of your NFA, then this whole machine accepts. So that's what this is saying. All right. Well, that's a bit long-winded. Now, can you remember in the proof we split it up into two, the easier part and the harder part. The easier part did not include these eta arrows. Now we need to go back and do the second part of the proof. So we modify what we did in the first